Okay, we have here on the board another odd even problem, and we're asked to decompose just the function e to the x into its odd and even parts. And we actually have the formula to decompose it right here that I used in the previous video. One thing, I actually already did this problem, decomposing e to the x. I just kind of wanted to do it a little bit different way. So to get started, I want to just make clear that this e to the x is going to be our f of x that we're trying to decompose. And then we also can find our f of minus x that we're going to need for this formula. So f of minus x is going to be just e to the minus x. Then one thing to mention before we really get into it, e to the x is not an even or an odd function. And let me just quickly go over the definition for an odd and even function. So for an odd function, if we have f of minus x, it's going to be the same thing as minus f of x. So if e to the x was an odd function, we wouldn't have e to the minus x here, we'd have minus e to the x. And then the definition for an even function, if we have f of minus x, it's going to be the same thing as f of x. And again, we see here that it can't be an even function because here we would just have e to the x. So let's just go ahead and we'll use this formula, and this should break up our e to the x into its even and odd parts. So our f of x value again is e to the x, and we'll just use the formula. We're going to have 1/2 e to the x is going to be this value, e to the minus x. Then here again we have e to the x for our f of x minus e to the minus x. And then one thing I can do with this is just subtly rewrite this. For the 1/2, I can write it as a 2. I can write it like we're dividing by 2 and do the same thing here, writing it all over 2. But this is actually our definition here. This is the definition of cos x, or the hyperbolic cosine. And this here is the definition of sinh x, or hyperbolic sine. And so cos x is going to be our even part, sinh x is going to be our odd part. And so this is going to be our decomposition. Before I finish up, let's just show to make it really clear that this is an even function and this is an odd function. Okay, so we'll start here with our even function, fe of x. And then what we want to do is we just want to look at fe of minus x to show this is even. So we'll take this definition here and we'll just plug in a minus x everywhere we have an x. So here this is going to become e to the minus x over 2. But then here minus and minus is going to cancel. I can just reorder these things. I can bring the e to the x first and the e to the minus x second over 2. But this is the same thing as this definition here of cos x. So this is actually the same thing as our original function, and that's actually the definition of an even function. And then we'll do the same thing here with our odd function. We'll look at f sub 0 minus x. Now using this definition, plugging in minus x everywhere we see an x, we're going to have e to the minus x minus e to the minus x over 2. Again, minus and minus is plus. Now with the minus sign here, we can't change the order the same way we did here, but we can change the order if we bring a minus up front. So I can bring a minus up front, and then we can write this as e to the x minus e to the minus x over 2. But then this piece right here is actually our sinh, so I can write this as minus sinh of x, or minus f of 0 of x. But again, this is the definition of odd, just being able to take the minus off the x and basically bring it out front. So that's it, kind of just a simple example of even odd decomposition. We'll stop it there. Thanks so much for watching. Have a great day.